So I think we can start. So today, as you've seen, we're looking at inequalities. Before we proceed and look at inequalities, I want us to look at this equation. Let's look at this example of an equation. So we have that equation to solve. Solve the equation negative 2x plus 7, which is equal to x minus 11. Okay, so for us to solve this equation, as usual, we are going to collect the like terms like this. So we have this minus 2x minus x being equal to minus 11 minus 7. And then we're going to have minus 3x this side being equal to minus 18. So that's what we have there. Then you can divide both sides by minus 3, minus 3. Then you have that x is equal to 6. So today we are going to be talking about the solution set of equations and inequalities. So in this case, the solution for the values of x for which this equation will hold is 6. When x is 6, this equation will hold. So you have that the solution set, which we are going to call the solution set of this equation here, is simply 6. So that's what we have there. So that is the solution set for this equation here. So let's look at inequalities now. Let's look at this linear inequality. Solve the inequality. Minus x minus 3 being greater or equal to 2x plus 7. Okay, so we have that inequality. That's a linear inequality. So we are looking for values of x for which this inequality is going to hold. For example, minus x minus 3 greater or equal to 2x plus 7. So as usual with this one, we are going to collect the like terms. So we have minus x and minus 2x this side being greater or equal to 7. With this one, it's plus 3. So you are going to have here this side, you're going to have minus 3x being greater or equal to 10. Then we're going to divide both sides by minus 3 by minus 3. And I'm sure you know what happens when you divide to the sign, when you divide by a negative number both sides. So you have that x is less or equal to minus 10 over 3. So that is the solution set for this inequality. So this inequality is going to hold for all values of x such that they are less or equal to negative 10 over 3. So in this case, the solution set to this inequality is equal to OX such that x is less or equal to minus 10 over 3, of course, this x is real. That's what we have, or which is equal to minus infinity all the way up to minus 10 inclusive, like that. So that will be the solution set for this inequality. I'm sure that's clear enough.
Yes, sir.
So next, let's look at, that was a linear inequality. Well, let's look at an example of a quadratic inequality now. Inequality. So you can look at quadratic inequalities. Example. So you have 1. So find the solution set to the inequality x squared plus 5x so that's what we have there. So find the solution set to the inequality x squared plus 5x plus 8 greater or equal to 2. So as usual, we want to find all values of x for which this inequality is going to hold. In this case, this is a quadratic inequality. And as usual, you know how to deal with quadratic equations. So you are going to factorize this one here. And then you can do some rearrangements there. So you have this one will become x squared plus 5x plus 8, then this 2, then this will become greater or equal to 0. Then we have that this is x squared plus 5x, then plus, what's that, 6, which is greater or equal to 0. That's what we have. Factors, you can see 2 and 3 there. So you have x squared plus 2x plus 3x plus 6 being greater or equal to 0 there. Then we have this x out, you have x plus 2 here, then you have the plus 3 out, you're going to have the x plus 2 there, which is greater or equal to 0. Then you have that this is x plus 2, you're factorizing x plus 3 being greater or equal to 0 there. So when you reach this stage, we are going to find what we call critical values. So you find critical values. To find critical values, we equate this one and this one to 0. So we have x plus 2 being equal to 0, then x is equal to minus 2, then this one x plus 3 being equal to 0, which will imply x is equal to 3, negative 3 there. Then these are the critical values. So the way we're going to deal with these critical values is as follows. So you're looking for, so you're going to make this table. So just pay attention there. So you're going to make this table as follows. This. So we seek to find all values from, say, from minus infinity. By the way, this one is greater than this one. So we seek for values from minus infinity to -3, and all values between -3 and -2, and then we also have these values from -2 all the way to positive infinity. So that's what we are going to have. On this side, we are multiplying this one with this one. Then we are going to say, okay, x plus 2 there, your x plus 3 there, and then your x plus 2 and x plus 3 there, the product. So we want to see what is happening to this expression here in this interval. Also, we want to see what is happening to this expression in this interval. Also, we want to see what is happening to this expression in this interval. Infinity and -3, we are going to pick any value which we are going to call a test value. So -3 here, we can pick -4 and plug it in there. So -4 plus 2 will give you a negative number. So this here in this interval, this will be negative. But the same -4 in this interval is going to be a negative. And then we are going to multiply here. A negative times a negative number, you are going to get a positive number there. Okay, cool. So let's look at this interval now. So you pick a test value between -3 and -2. So you're going to have, okay, which value lies between the, okay, let's pick, for example, 2.5, -2.5. So when you pick -2.5, you put there, you see you're going to get a negative. And then when you put -2.5 there, you see you get a positive number. And the negative turns positive here, you're going to get a negative number. Then, cool. What is happening in this interval from -2 all the way to infinity? So you also pick a test value here between -2 and infinity. Which value can we pick? Let's pick one. You can pick -1. School, as long as it's between this interval. So when you pick -1, you're going to see that when you plug -1 there, you're going to get here, you're going to get a positive there. -1 there, you're going to get a positive. Positive times positive, you're going to get a positive number. So you're going to see, guys, when you get back to our inequality here, positive number. So you have positive numbers in this interval and this interval here, -2 to infinity and -infinity to -3. But we have an equal sign here. So we are going to discover that -3 is inclusive. Also -2 is inclusive. Because when you put -2 there, you are going to discover that this will be a 0 and this is equal to 0. So this inequality will hold. And then -3, the same will happen, this inequality will hold. So therefore, the solution set to this inequality now, the solution set will be equal to OX such that X is between this interval. But here to change, let's O equal to -3 because all in this interval here, -2, where X is greater or equal to -2, then all the way up to positive infinity. And of course, there X is a real number. All this solution set here is the same as, so you have this interval here where X that inequality is holding all the way up to -3, then union this one here. So this one -2 inclusive all the way up to positive infinity. So that is the solution set for that quadratic inequality. So we are not considering this interval here from where all the real numbers between -3 and -2, but -3 and -2 are holding, so you include them here because -3 is going to equal 0. Also -2 is going to equal 0 there. Okay, so let's look at our second example on quadratic inequalities. So let's look at example
what's
2.
the solution set for this same question that we're from doing?
This is the one here, which is the same as this one here. So we have this here. So I said the solution set is equal to this one here, x between this interval and or between this interval here. And then we have that this is the same as, you can write it in this way. So it's the union. So all values in this interval and all values in that interval there. We okay?
Okay. Yes, thanks.
So let us look at example 2. So we are finding solution set for 2x squared plus 7x minus 15 less than 0. So that's what we have there. Okay, so we are going to factorize this one. Okay, the product here factors of 30, we have 1, 2, 3, 4, 5, 6, we have 10, we have 15, and 30. Okay, so we can pick 3 and 10 here. Okay, so we have this one is going to be 2x squared. Then we have plus 10x. Then you have minus 3x minus 15 being less than 0. Then you have 2x there. Then you're going to remain with x plus 5. Then minus 3 there. We're going to remain with x plus 5. This being less than 0. And then what we have here, then 2x minus 3. So we seek to find values of x for which this inequality will hold. So to do that, ladies and gentlemen, we're going to find critical values. We're going to denote them as CC, which you can get from here and here. So you have x plus 5 being equal to 0. And then we have that x is equal to minus 5. And then when you get 2x minus 3 to 0, you get x being equal to 3/2. Okay, then from there, we can do our table.
Excuse me, sir.
Yes.
Where's the 30?
Which one?
The 30.
Oh, the 30 and the 10. Oh, okay. So we are, have you forgotten how to factorize quadratic equations? So you get this product here, then you get the factors of the product such that when you multiply those So you get the factors, then you get two factors of the product, this one, 2 times 15, which is 30. Then you're going to find factors of 30, then you pick two factors of 30, which when you multiply, you get 30, and when you add, you get 7x there. You get a 7 here. So we picked 3 and 10 because I know, for example, 10 minus 3 will give me a 7 here. And 10 times minus 3 will give you a negative 30 here, which is negative 30, by the way. I don't know if that makes sense.
Yes, thank you.
So upon finding those two factors, then you can subtract negative 3 there. And
You said it gives you.
okay, so let's continue. Here, so you're going to form those intervals to find the solution set. So we are multiplying this one by this one and see which one is going to be less than 0. So we consider values from, let's see here. So you make the table. So you're looking for values. So we get these values here. Are we able to see with that pen? Okay, I think it's visible enough. X, then all the way up to minus 5. Then we are going to consider also this interval from minus 5 to minus 3, to positive 3 over 2. So we have minus 5 being less than x, which is in turn less than 3 over 2. Then we are also going to consider this interval here from 3 over 2 all the way to infinity. Okay, so here we have this one, x plus 5, and 2x minus 3. Then we have the product here, x plus 5, 2x minus 3. So at this moment, ladies and gentlemen, so we're going to find, you pick a test value between minus 6, okay, it's be a negative number. Then here, minus 6 here, you see that you're going to get a negative number as well. Then negative, you get positive, ladies and gentlemen. Then in this interval, you have from minus 5 to 3 over 2. So you can pick any test value here. Say, okay, let's pick negative 4. So that is in that range. You can pick 1, it is in that range. So you can pick any number which is in this range. So let's pick here.
Sir, we can't see what
example,
you're writing down there.
Where? Are you sure?
Yes. Try to, I don't know if it's to lift the camera a bit high.
But I'm able to see very clear here.
Or I thought you were writing something.
I'm not writing anything.
Oh.
Okay. We're saying minus 3, for example. So minus 3, when you put there, you are getting a positive number. And when you put minus 3 there, minus 3 times 2 is minus 6. Minus 6 minus 6, you are going to get minus. So minus, positive times minus there, you're going to get minus. In this range, you pick a test value. Let's pick 2. 2 there, you're going to get a positive number. 2 there, you get a positive. Positive times positive, you get positive there. So you see, no positive number is less than 0, so forget about this. So a negative number is the one which is less than 0 here. So this is what we are going to have. But we are critically looking for values of x which will less 0, which will be less 0 here, not less or equal to. And you see, when you put -5 there, it will be 0. This 0 is not less than 0, so -5 is not inclusive in our solution set. 3/2, when you put there, you still get a 0, which is not less than 0, so it is not inclusive of our solution set. So in this case, the solution set critically lies between -5 and 3/2. Here at -5, the solution set okay, let me write it here. So the solution set for this one will be OX such that x is between -5 and gentlemen, x is a real number here. So that is the solution set. Or if you want, in this other form, it's -5, not inclusive, all the way up to 3/2, not inclusive. So that is the solution set for this one here. So that's what we have there.
Excuse me, sir.
Someone is disturbing there.
Sir. Is a test timetable really needed
Just a moment.
finding the So I want to ask a question.
Yes, I can get you.
Sir, I wanted to ask a question.
Yes, what question? Sorry, just a minute. Okay, what's the question?
I wanted to ask, is the timetable really necessary when coming up with a solution set?
This table?
Yes, the sign table. Is it really necessary when coming up with a solution set?
This same table? No, there are other methods, and this is just one of the methods. There are other methods, of course. Are we okay?
Continue, sir.
Yes. So
You can
let's proceed.
continue, sir.
Okay, so away from quadratic inequalities, we can look at polynomial inequalities. Okay. Today we are working with examples. So we look at an example. So solve the polynomial
So we can't see anything. Can you please show your screen?
Okay. You're able to see now?
Not yet.
Not yet.
You're not able to see.
No,
No.
just the face.
Oh, something is wrong here. How about now? You still can't see?
We're able to see now.
You're able to see.
Yes.
Okay, so we leave it there. I'm sure people will be seeing. So just tell me if you'll be able to see. Just you able to see?
No.
Okay, okay. Let's use this one. Okay. I don't know what happens to my Zoom camera when I join a meeting. It becomes blurred, so I use the other camera. Okay, but I'm sure this is visible enough. Okay, so solve the
Yes.
polynomial inequality. So you have this inequality here, plus 3x squared minus 3x minus 2. This is less or equal to 0. So we have a polynomial of degree 3 here, and we want to find the solution set for this polynomial here. So first thing first, we are going to factorize this polynomial here. What did we say about how to find? So first you find one factor, and the possible factors we said first you consider a0, which is equal to minus 2. You also consider an, which is equal to 2. Possible factors we have plus or minus 1, plus or minus 2. Here, factors of this one are these, and the factors of this one here are these. So use the trial and error. You can't see.
Yes.
Wow. What are we going to do?
That's I can see.
Yeah, but it's visible here. Okay,
So we
so
can
from
see.
here,
Very.
oh, you just a bit, yes, if you say a bit. This one here, you are going to, okay, let's try +1. So you find f of 1. So you can let this one equal f of x so that you find f of 1. So this one will be equal to 2 times 1 to the power 3 plus 3, 1 squared minus 3 times 1 minus 2. So this you are going to discover that this is 2 plus 3 minus 3 minus 2. Here it's a 0. This and this is a 0. You see this is equal to 0. So from what we looked at
Excuse me, sir.
the previous page,
Are those numbers or letters there where there's -2 and +2?
oh,
Is that
these
9?
are, this
And I'm
is
saying
2
on top there.
plus,
There on
on
top
top.
there. The polynomial equation now below, there's I don't know if it's 9,0 is equals to -2.
Oh, this
What's
is
that?
A naught, A naught.
Okay.
This is A naught, which is this one, and AN, which is equal to 2.
All right.
Yes. So guys, so since f of 1 gives us a 0, then you are going to have that x minus 1 is a factor of this polynomial here. Then from there, you can use your long division or the synthetic division. Let's use the synthetic division. So meaning here x is equal to 1 when we equate this one to 0. Then by using synthetic division, you're going to take all the coefficients of the polynomial. You have 2, 3, minus 3, and minus 2. So you're using 1 here. So you have a 0 there, then the 2 can come down there. So what are we going to have there? This is 1 times 2, it's 2. 3 plus 2, you get 5. 1 times 5, you get 5 minus 3 plus 5, you get 2. This times this one, you get 2. Then minus 2 plus this one is equal to 0, which is equal to the remainder. And then from there, you can see that. So this, the quotient now will be 2x squared plus 5x plus 2. Okay. These people, let me try to use this other camera. Just tell me if you'll be able to see. This one is. Are we seeing?
No.
No.
No, sir, we've stopped seeing anything now.
What's wrong with my Zoom? Because I've shared my screen here. Let me just try to share. So we're going to, okay, I stopped sharing my screen. I didn't notice that. Okay, I'm sure we can see now.
Yes, sir.
Yes, sir.
Okay, so from here, you see that this your polynomial is going to be written in this form. So you have 1 factor x minus 1, then times this one here, which is 2x squared plus 5x plus 2. But this, we are saying this should be less or equal to 0. And here you're going to factorize this one now, which is very simple. This is 4h. So you're going to get something like this. Okay, so please factorize this. You're going to get this. So you're going to get x plus 2 and 2x plus 1, which is less or equal to 0. Then again, from here, what are we doing? We are going to find test values. I mean the critical values here. So the critical values, you equate this one to 0. You're going to discover x is equal to 1. Then this one, x plus 2 equal to 0. X is equal to minus 2. Then 2x plus 1 equal to 0. X is going to equal minus 1 over 2. So that's what we are going to have there. Then we can use this table. I prefer the table, but you can use what you'll be comfortable with. So here, so you discover that we are going to have 4 intervals. So the first interval, okay, this one is lesser. So you have from minus infinity all the way up to minus 2 there. But we also have this interval here from minus 2 to minus 1 over 2, minus 2 to minus 1 over 2. Then we also have this interval here, minus 1 over 2 to, so we have that. Then we have another interval from 1 all the way up to positive infinity. Okay, so we want to see what is happening here. We want to see which values will be less or equal to 0 there. So we have x minus 1 there. Then we have x plus 2 there. Then we also have 2x plus 1. Okay. So in this interval, you can pick a test value. Let's say we're going to pick -3. So -3 minus minus there, you're going to get minus. Then -3 plus 2, you get a minus. Then here, when you plug -3 there, you still get a minus there. So you have this one times this one, positive, negative. So you get a negative in the product there. Then in this one interval, so you have -2 and -1 over 2. Here you can pick -1. -1 there, it will give you a negative number. And -1 there, it will give you a positive. -1 there, it will give you a negative. Negative times negative, positive, positive. So you have a plus here. In this interval, from 0.5, -0.5 to 1, you can get 0 here, it's fine. 0 is in this interval. So there you get a negative, there you get a positive, there you get a positive. So here, positive, positive, negative. So you get negative there. Then in this interval, you can pick any number here, 2, for example. 2 there, positive, 2 there, positive, 2 there, you have positive. So, and the product will be a positive number. So when you go back to your inequality here, so the values will lie somewhere here in those intervals. So in this interval and in this interval here. So how is the solution set going to look like? So the solution set will look like something like this. So OX values such that, by the way, here we have an equal to sign. So -2 here is inclusive. So X in that interval less than X, which is less than or equal to -2. All in this interval here, this one here, which is -1 over 2. -1 over 2 inclusive there because it is 0.
The phone is shutting down.
It's shutting down.
Oh no.
Oh no.
No, shut down. The class is just done, isn't it? It's almost 18 hours anyway.